Hello, my name is Aaron Leith, and this is a video to document my demonstration project for MAE 535 with Dr. Buckner at NC State University. Go Wolfpack. My original intention was to build a wind generator, wind turbine, but a couple of calm days outside and me having some difficulty in building a machine that would harvest enough energy at low wind speed led me to just building a simple generator, which I think demonstrates the principles equally as well. So the principle that we're talking about here is Faraday's law of induction, which states that voltage is induced by a changing flux linkage, changing in time typically. And a flux linkage is described as a number of turns or coils and a flux through it. Flux described by a magnetic field through an area. So when we have a fixed coil with a fixed number of turns, and we use a permanent magnet, as I did, I used ceramic magnets, 6 of them, then the only thing left to vary is the speed at which the field moves across. In other words, how quickly the magnetic field sees a change in area across the coil. This is done by spinning magnets around the coil, and I'll show you my generator here in a minute and give you a quick description of how it's constructed. Okay, so here we see the generator setup. To the left of the screen I have the generator here. It is a PVC disc, the 1-inch hole in the center. These are ceramic permanent magnets that have been epoxied onto the PVC. There's 6 of them there, and as you can see their polarities are alternating. The stator is consisting of 6 windings of 32 gauge magnet wire. They're wound in opposing directions, alternating directions. So for example, this winding here is wound in the clockwise direction, while this one is wound in the counterclockwise direction. This is done so that as the flux changes in each one, this coil, for example, will see a north-facing flux, while this one sees a south-facing flux. So if they were to be wound in the same direction, they would produce opposing currents, and we wouldn't get a whole lot of usefulness out of the system. A little bit about the construction here. This is a hole saw, as a matter of fact, that I used to construct the thing. Turned out to be quite useful as an axle. This is a simple thrust bearing. It's just sitting on top of a spacer. So this whole system goes together quite simply, like such. What you see on the right side of the screen is a kit, like sensor kit type thing. There's nothing going on here. I'm just using the breadboard and the spring terminals as my means of connection because I haven't got any soldering equipment. The wiring circuit that we have going on here, we have the coils that come off of the stator and are fed to these spring terminals where they meet a rectifier. The rectifier is going to change the AC voltage coming off of the coils to a DC voltage. Have jumper wires leading from there onto the breadboard, which allow the current to pass through this red LED here. I have another set of jumper wires that I've taken from either side of the LED, allowing me to read the voltage of this circuit. So we'll give it a spin here, and let me dim the lights first. We'll give it a spin and see if that LED lights up, and we'll also keep an eye on the voltmeter here and see what happens. So as we can see, we're getting some light. I don't think it shows up very well in the video, but it's certainly there. The voltmeter was showing about, let me see if I can get out of the way, was showing about 1 volt. So we're getting about 1 volt and it's lighting up.